My name is Cliff. That's my Twitter handle, Cliffano. I work at Sensis, and one of my responsibilities is to maintain our Jenkins instance. This talk is about, it will introduce Jenkins for those who don't know it yet, and we'll also dive into continuous delivery, what it is and what the practices are. And I'll show you a bit of a demo on showing how Jenkins can be useful for continuous delivery practices. A bit about me and Jenkins. I started using it since 2007, started contributing a year later. My first contribution was the Firefox add-on. At that time, I thought it's just a once-off thing that I just left there, and I still maintain it up to today. My most recent contribution is Nester, which is a Jenkins command line interface written in Node.js. It's much faster than the default Java CLI, and several other plugins. Okay, a bit about Jenkins. Who here already used Jenkins? Show of hands. Anyone uses other tools other than Jenkins? Cool. Anyone not using any continuous integration tool? Okay, nice, thanks. Right, so Jenkins brands itself as a continuous integration server. I like to look at it more like an automation framework. It started getting popular for Java-based projects, but in recent years it's used by, since it was written in Java, so that's how it got really popular in Java community. But we at Sensis use it to build iOS projects, Rails apps, Node.js applications. So it's not tied up to Java anymore. And there is a recent effort of extracting all the Java-specific tools, things like Maven and plugins, from the core code into external plugins. And I believe someone is actually working on hooking up Jenkins to automate vacuum cleaning the house, the carpet. So I can look at it just a pure automation framework later on in the future. It was created by Kosuke in 2004. It was actually named Hudson back then. It started getting popular in 2008, but unfortunately in early this year, the original community decided to rename the project to Jenkins for political reasons. Some of the features are, it's really easy to install and upgrade. It's easy to configure. It has a web UI. Back then, I used to use cruise control, and I hated a lot having to configure XML upon XML upon XML, and I started using Jenkins. It's just so easy to use. Same thing with distributed builds. It was such a painful thing to set up for cruise control back then. I really like having distributed build support in Jenkins because it just makes it easy if you need to build and test your applications on multiple platforms. So you can run a build on Solaris, Linux, any operating system. If that's a HTTP API, and that's how you hook up external clients to Jenkins core services. It has a vast array of plugins, about 400 plus and counting. One reason why it became really popular and with the contributors is Jenkins has an update center, which you can look at it like a Firefox add-on website. So as a developer, I'm not worried about where to publish my plugin. It just goes to the update center, and then for people to use it, it's just a matter of clicking and install. It also has a great communities, very active mailing list, 100 plus code contributors and counting. Yay, demo. But for those who are not familiar with Jenkins yet, I'll show you this instance called Jenkins on Jenkins. So Jenkins project uses Jenkins to build Jenkins core and plugins. Let's pick one. Let's pick the Chuck Norris plugin. Yay. Right, on the left you can see the build history over there. Each orb indicates the status of the build, blue being successful, red being fail, and there are some other colors. Anyone know why blue was used instead of green? No? Yeah, good. Yeah, colorblind, most colorblind people, I think they can't differentiate between red and green. And there was a passionate discussion on why was it blue by default, and someone actually built a green ball plugin which just turned blue into green. So that's quite interesting. Right, so on the right side, you can have a look at some of the charts for quality metrics, test trend, and disk usage. You can plug any sort of reporting to any build. And to build, just click Build Now. Yep. So it will show up as an active build in the history. And on the main dashboard, you'll see it in one of the executors. So that's the distributed build support, having, in this case, a single master and several slave executors. Okay, going back to the presentation. Right. Continuous integration. I think it started getting popular when Agile came up, and by now, probably about 10 years since then, I think we're all pretty good with continuous integration. I believe most companies have automated compilation, quality metrics, testing, package, deploy, and yeah, continuously for each development, throughout the development cycle, you actually apply quality control. Anyone not actually applying any continuous integration practices? Okay, good. I think we're good. Yeah. Right. The common setup that I've seen on most companies is something like this. So developers will just commit code to source control, so push, pull, and then Jenkins or any other CI tool will just download the code from source control, compile, apply some quality metrics, and then publish it to an artifact repository like Nexus or Artifactory. And then come the release time, then you can configure a Jenkins build to the deployment to development or test. And that can be done on each commit, each code change, or any schedule that your project actually are comfortable with. And depending on the companies, some companies actually have an ops group that controls staging and production. And you can still automate Jenkins to deliver the code to ops to deploy. Right. Before jumping to continuous delivery, the thing that triggers this idea of continuous delivery is if you need to make a single line change in your product, and you have to make the change in production environment, not directly as a cowboy way, log into the box and make the change, but throughout the proper cycle, throughout you make the change, commit it, and then run the test, and then deploy. How long does it take your company to make the change in production? In 1 hour? 1 day? Oh, cool. 1 day? Yep, so it's pretty good. 1 week? Right. So with continuous delivery, compared to continuous integration, when everyone raises hand, I don't think we're there yet with the practices. There are still so many things to explore. I believe the development team and testing team pretty much get the idea of being agile. Ops is starting to get into that movement with DevOps, and probably the business will be the last to catch up. Continuous delivery is quite similar to continuous deployment, but with the emphasis on focusing on production. So when you develop the code, you develop it in an environment that's production-like. The benefit of it is that, for example, if you have a production environment with a cluster of databases, but you develop on an environment with just one database, most likely during staging and production, you'll find an issue with something like database replication. And then the tester will say, hey, this feature doesn't work, or it has this problem, and then bounce back to you. But it's hard for you to reproduce that in your dev environment or your test. And then it goes bounce back and forth, and you're wasting time. And the other thing is performance tests. Most of the projects I've seen, they put the performance test implementation a bit in the middle or at the end of the project cycle. So putting the performance test scripts or automation upfront is really beneficial. And the ultimate goal is also to minimize the cycle time from idea to delivery. When you have, say, a web application product and you have this new idea you want to apply, you shouldn't wait really a long time to deliver that feature just because your production life cycle is 3 months or 6 months. Your competition certainly won't wait for you. So one thing about it is about shorter release cycle. And this is quite interesting because the author of Jenkins mentioned it in one of his interview that back then he was quite frustrated. He was working on JXB, and the proper production release cycle is about 3 months for new releases to go up. And he asked, well, why not 3 hours? If someone submits a bug and it's an easy fix, why do you leave your code there in your source control for 3 months without any value for your millions of users? So yeah, 3 hours is probably a bit too extreme, but you get the idea. You want your fixes, your new features to not just sit there in your source control, but to get it out there to the users. And with frequent releases, you also get rapid feedback. One benefit could be, say, if you're changing your website to, let's say you start with a website that doesn't require any authentication to leave a user comment or a review. And then suddenly you want to change that to, hey, let's introduce OpenID. And then you go through your normal cycle of 3 months release, and then you get it out there, and the result is people don't want to log in to using OpenID. And then you have to maybe introduce Facebook login or Twitter login. But then you have to wait for another 3 months to get it out there, and you don't even know how your users will react. So the question is, why do you wait for 6 months to fix something, and why do you wait 3 months to find out what the user would like? So a day or 3 hours is probably too extreme for a release, but the goal is really to adjust the release cycle and make it as minimal as possible for your project. And the other side effect from having more frequent releases is that instead of releasing 400 changes after 3 months, you actually release 4 changes in a shorter period of time. One benefit for the development team is that you can concentrate more on those new changes. The testing team can focus solely on those 4 changes. And then when you get it out there into production, if something goes wrong and your ops team get angry, you can be pretty much sure that it's probably one of those 4 changes. So you don't actually waste time going through 400 changes trying to figure out, hey, which one out of these 400 actually caused the problem. The poster boy for continuous delivery is Flickr. If you go to code.flickr.com and scroll down to the bottom, you'll see their plus deployment for the last week. So for this one, I took a screenshot of. They have 80 deployment to production per week. So assuming they only work 4 or 5 days per week, that's 16 deployment per day. That's like once every half an hour. And for each deployment, they only have 7 changes. So yeah, that's quite extreme. But wait, there is more. When it looks good for us, dev team, and probably testing team as well. But from the ops perspective, I talked to several people from ops. Their main concern is often, hey, it's gonna, well, the goal is to deliver the business value out there really fast. It's gonna help dev and test, but ops is always concerned about, is it going to actually multiply their costs? Say if a release for them takes 1 hour, for example, more frequent releases, does it mean it's going to translate to 1 hour multiplied by the amount of your releases? One way to counter that is to convince them that, hey, it's going to be easy to deploy. It's not going to cost you any further grief, as in pay attention to your regression tests. focus on your automated testing. And it's not going to be a complex deployment. So a release should be simple. For the person doing the release, it should be as simple as select which version of your product that you want to deliver, deploy to which environment, and then just push a button. So anyone can deploy, whether it's the developers, testers, ops, new team member. Etsy.com actually has an interesting practice. If you're new in the development team, on your first day, you have to deploy to production. So that's kind of a testament that the deployment process is really simple and it's all automated. And the other benefit of having simple deployment is that you can implement a pull system, whereas the owner of the environment can decide when to deploy. For example, the testers can just deploy any version that they want. So as long as you provide the simple select versions, select environment, and then click, the tester can just do it. And they can decide when they want to test a certain version and to which one of their set of servers. And you have to make sure that you don't have any environment-specific build, as in separating environment configuration from the builds. And when you have a deployment process, deployment automation, deployment script, make sure you use the same set of tools to deploy to all environments. So you're not only testing your application code, but you're actually testing your deployment mechanism. And if it works in dev, there is no reason why it shouldn't work in production, providing you have all this consistent environment. Another practice is called deployment pipeline. It's a sequence of stages or steps. It will be different between projects, of course. The common setup is you start with a commit stage, so that's what happens after you commit the code change. You can apply quality control, get all the report metrics, run unit tests, and then next step is acceptance tests. Ideally, that should be automated. For some products, you can't avoid having manual tests. Fair enough. And then you want to have automated performance tests as well. And then at the end, the release stage, like how you deploy your application. So I kind of look at deployment pipeline as a way to fight regression testing. As in, you shouldn't deliver your product without going through the steps. If you skip directly to production, say you log into a box and then modify the code, then you're breaking the pipeline. And in Jenkins, there is a plugin called Build Pipeline. Has anyone used Build Pipeline before? Cool. Yeah. So here's a simple example of how Build Pipeline can be used. So I have a project called Yoda. So that's a job, the first one, that will build the application. And then the next step is to publish. And the next step is to deploy to UAT. In my case, I have an EC2 instance. The source code itself is on GitHub. And then I run smoke tests, which basically checks whether the website is up after the deployment. And then just a dummy acceptance test. And then I pretend I have 2 production environment. So if you have a complex development, 5 servers, test, 5 servers, UAT, you have 10 servers, you can actually graph all these dependencies between environments, the flow in a nice pipeline. Each job can be linked through by configuring the upstream and downstream job. And if you have multiple paths, then it will just be a branch. So let's kick off a real deployment. Here's the website that we'll use for testing. And let's modify the code. So I just change it, and then okay, so that's changed on GitHub. And I'll kick off the pipeline, start with build of pipeline for Yoda. So the blinking orb means it's the active one, and it's colored yellow. The blue ones are just pending. So throughout the process, you'll see it move through the pipeline. Usually project managers like this a lot, and I kind of like it because I don't have to answer their question. Every time they need to know at what stage is our build on, or sometimes during after deployment, I get asked, is it there yet, or where is it up to? I just put a display for build pipeline on a monitor in the corner of the room, and then they can just check it themselves. Right, so it's deploying now to an EC2 instance. Yep, okay, that's done. So the code on the test side should be changed now. Okay. Do or do not, there is no try. Okay. Right. So is continuous delivery for everyone? I would say if you're starting a new project, then given enough funding approval from management, then yes, you can, and probably you should aim to have continuous delivery. I can see problems for legacy projects or projects where you can't really slice your releases into smaller chunks. Things like I know a project at a bank that they say they must have manual testing because they're dealing with real customer data, for example. And for the manual testing, it will take a day or two. You can't multiply that to 16 deployment per day, really. And probably you have a large data set that you have to migrate across, or you have to change the schema, and that will take 8 hours, then that's probably a problem as well. You can probably split the releases into just feature changes and the data migration separately, and you can still have continuous delivery for the feature changes. In conclusion, I think you get the idea that there is a value in continuous delivery. Is it for everyone? Probably not for everyone. And Jenkins is a useful tool for the automation. Yeah, so if you're starting your project, just make it so. And if you need automation, make sure you check out Jenkins. You won't regret it. Okay. Is there any question? Yep.
So the build pipeline, how do you handle versions? Like build a version and Git.
Yep.
And track that all the way through to what's in production.
Yep. Depending on how you version your applications, one approach is to have a snapshot builds for development. And then, so that pipeline is just an example. So after the acceptance test, you can actually hook up a job that have to be triggered manually, called, say, a release. So the automation bit is from commit stage up to acceptance test or performance test. And then once you're happy, someone with privilege to do the release can just kick off the next job in the pipeline and then assign a version to your product. And then you have and then it gets published to a repository, right? So say after a week you have 20 versions, then it's up to the next owner of the environment in the pipeline to decide, hey, which out of these 20 versions you want to pull to your staging environment or you want to pull to production. So yeah, that's how you can do it. Any other question? all good.